All right, let's look at a question. So, anytime we're given a particle moving in simple harmonic motion, or SHM, not Swedish House Master, we can assume that we can have this particular type of motion, right? Angus, what was that condition I gave you with x double dot, or the acceleration? Yeah. X, right. So you may not always use this property, but just keep in mind, if it is moving in simple harmonic motion, you can use this, right? But in this question, it seems like we're just trying to find the equation of its displacement, and we're given all the kind of information we need. Because remember, at the end of the day, these are just trig equations, the displacement functions. So we got some initial information. So initially, we're thinking what? So t is equal to 0, x is equal to 5. I'm just kind of jotting down the information that we have. What other stuff do we know? We've got period. So the period t, capital T, is pi on 2. So what that means is, if you think about your equation, and what is the displacement equation, we can assume that it is of the form a cos nt plus alpha. Okay. Now, so just to note, on your formula sheet, they use a little a here, but I always get that confused with alpha, so that's why I'm using a capital A. So we've got this form, we've got some of this information here. Anything else I haven't got yet? Where did this go? Amplitude is equal to 5, right? So, yeah, I did. I didn't write it down there. So, how can we put this? How can we actually form the equation now out of all this info? So that should be single x. Sorry. Put all in. Yep. So what we're going to get? X is equal to. We have a is 5. What about our n value there? Do we have that? 4. Yeah. How'd you do that?
2 pi on.
Yep. So just remember this part, and you solve the equation, n will equal to 4. So that's 4t. Now, well, we still kind of have this alpha here, right? Which is, well, that's not the complete equation. Right, so then we have to use that information there. So at t equals 0, x equals 5. So we can say 5 is equal to 5 cos, that's just 0, that's alpha here.
Cos of 1 is.
Have I done something wrong? Oh, I think the question said originally -5. That's right, we'll just do that. We'll roll with this. Let's make it -5 because, yeah, the question originally said -5, sorry. So yeah, that should be -5, my mistake. Sorry about that. Now, when you do this, when you find cos alpha, so inverse cos alpha of -1, so cos alpha will equal to -1, so alpha will equal to pi, right? So our final equation is going to be x is equal to 5 cos 4t plus pi. One thing I want to note is that often what they'll do with something like this, there's a property, if you remember back in year 11, that if you take cos of theta plus pi. Is it sine?
Or is that half? Is there one thing where you shift it?
Yeah. So the complementary ones are. I got to think about that one. I can't remember. This one is the negative one. Yeah. So it becomes negative cos theta. So what would be for sine theta?
Probably pi on 2.
Yeah, might be. Sine, cosine. So because they're complement, I think it's like pi on 2, yeah, minus theta. Yeah. So yeah, that's why it's the cosine, the complementary sign, right? So we can actually, they'll actually often rewrite this in a different way. They'll say x is then equal to -5 cos 4t without the phase shift, right? So these are equivalent here. Typically, they'll leave it in this answer there, okay?